So here is how we calculate this common difference D. What you would do is you take two successive terms and you subtract them. So D, in this case, you take the second one minus the first one. It's got to be in that order. So that's positive 17, right? So in this case, it says determine the common difference, D, which we just did, and find the next four terms. And so the next four terms are going to be negative 2, 15, 32, 49. Cool? Yep. So this is an arithmetic sequence because each successive term is the same number added to the one before. Yeah. Okay, so for next class, I'm actually gonna, move the chairs around, and I'm gonna have like a different seating arrangement in here, just because okay. I'll try to zoom in as much as I can. Okay. So now, how do we find the nth term of an arithmetic sequence? Okay, so there are lots of formulas in math. You guys know this. But I hate having students memorizing formulas, right? So here's what we're going to do. What I want you all to do actually is don't work on your calculators just now. Put your calculators away for a minute. So here's what we're going to do. Suppose you have a sequence, and the first number is 5, A1 is 5, and D is equal to 2, right? So what would the numbers be then? The first one, right? So let's write down all the numbers. A1, A2, A3, A4, A5, and then we're going to go to AN, okay? So A1 is 5, right? A2 is 5 plus 2. Then 5 plus 2 plus 2, so 5 plus 2 times 2. Then 5 plus 3 times 2. Then 5 plus 4 times 2. So what do you notice every single time when we do a process like this one? Every single one of these is 5 plus some multiple of 2's. And what's that multiple of 2's? N minus 1 of the 2's, right? So when n is 3, you add 2 2's. When n is 5, you add 4 2's, right? So then when I come over to this side, then it's 5 plus n minus 1 times 2, okay? So the general formula would be A1 plus n minus 1 times D, okay? This is called the explicit formula to find the nth term of an arithmetic sequence, okay? All right. Now, to find the recursive formula, right? To find the recursive formula, you just say A1 is whatever value, and then AN is AN minus 1 plus D, okay? All right, so let's do some of these here. Let's find an explicit formula and a recursive formula for the nth term of the arithmetic sequence. Okay, so first one here, A1 is equal to 4. And how much is D?
Wait, 14 now?
14. How much is D? 3 minus 14, negative 11. So for the explicit formula, you just do AN equals A1 plus n minus 1 times D. Okay, so now the question is, Ms. Milligan, do I have to memorize this? I mean, yeah, you have to know it by heart, but again, this is why I went through the whole thing, so that you can just reason it out even if you forget, okay? So AN is going to be 14 plus n minus 1 times negative 11. It's A1, the first term. And then we're going to distribute. So AN is 14 minus 11n plus 11. So finally, it's negative 11n plus 25. So this is the explicit formula for that sequence. Okay? All right. So now let's do a recursive formula. For the recursive formula, you just say A1 equals 14, semicolon, AN equals AN minus 1 plus or minus 11. How does that sound? Yep. You know how it's like location, location, location? In math, it's all notation, notation, notation. So you got to have, that's a new one. I just came up with that. You have to have the semicolon there. You have to have, you know, like it's just, yeah. Mm-hmm.
Are those, like, are they the same thing? Will you get the same?
Yes, except with this one, you can only find the very next one. So if you want the 57th term, you have to use number 56, right?
Oh, so then we have to.
Right, so you have to, so for this one, you can only find the very next number of what you're on. So if you want number 57, the 57th term, it has to be, like you have to start from 56. But for this one, you can just jump to 157 if you want, okay? All right, so here, so like this one, find the 41st term of the arithmetic sequence here. Okay, so I have 1, 2, 3, 4. Now you can either sit there and like add, or you can find a formula for it and plug in your numbers, right? Which is exactly what we're gonna do. So A1 is 11, D is negative 7, and how much is N in this case? 41. So here's what you do. You do A sub 41 is equal to A sub 1 plus N minus 1 times negative 7. And remember we said N was 41. So A sub 41 is 11 plus 41 minus 1 times negative 7. And that happens to be negative 269. Right? So you see how we just jumped into that sequence, right? We weren't going to sit there and like subtract 7 40 times. That's just silly, okay? No, not for this one, okay? All right. So next one. So these are a lot of like, we call them plug and chug, right? It's basically like, you know, just working with the formula. So here you want to find the first term of the arithmetic sequence for which A44 is 229 and D is 8. So one way is, okay, you're adding 8 every step of the way. One way is subtract 8 43 times. But that, I mean, seriously, like we have a life, right? So we're just going to plug it into the formula, okay? So what's the formula? A sub n is A sub 1 plus n minus 1 times D. Okay, so 229 is A sub 1 plus n minus 1, 44 minus 1 times 8. So 229 equals, how much is that? It's A. How much? Is it 344? Okay. So then A sub 1 is 115. Okay. All right. Okay. Questions? Okay. So, arithmetic means when you have an arithmetic sequence, and suppose you take two random numbers that are non-consecutive. All the other numbers that come between them are called the arithmetic means between those two, right? So these numbers are the arithmetic means between 7 and 47, okay? Yep. Okay, so take a look at this. Write an arithmetic sequence which has 5 arithmetic means between 6.2 and negative 1.6. So what we have to do, right, is here's the sequence, 6.2, 5 new numbers, wait, 1, 2, 3, 4, 5. And then it's negative 1.6. So we have to find all of those numbers. Okay? So we first need to find D, and then we can figure it out. Okay? So what's A1 here?
6.2.
And what's A sub n? That's the last one always. Is negative 1.6. It's the last term, right? So how many terms are there? 7. So this is really A sub 7. It's negative 1.6. Because n is 7. So what we want is to find D. Yeah? So let's find D. An is A1 plus n minus 1 times D. Negative 1.6 is 6.2 plus 6D. So this is negative 7.8 equals 6D. D is negative 1.3. Okay. So now that you find that's what D is, what are you going to do? You're going to subtract that number from each of these. So minus 1.3 gives you 4.9. Minus 1.3, 3.6. And then 2.3, 1.0, negative 0.3, and so on. Questions? Yeah.
What are you doing in the AN equals A subscript 7 equals sorry, I'm mixing it up in my head. But A subscript n equals A subscript 7.
So A sub n is the last term in the sequence that you're looking at. Okay, in this case, because n is 7, the last term is also A sub 7. Which is negative 1.6. Okay, so students are always like, when I teach the students are always like, hey, Ms. Malikin, can't you just subtract these two and divide by how many steps there are? Well, yeah, but isn't that exactly what we just did? We just subtracted those two and divided by how many steps there are, right? That's exactly what this formula does. Okay?
But we have to write it.
I mean, you can just start from here. That's fine, yeah. Okay? Okay. So, okay. So, what this is, right, an arithmetic sequence, whenever you subtract any two consecutive terms, like here you get negative 1.3, here, for all of these you get negative 1.3, right? That's what an arithmetic sequence is. These in the red, those, the differences, these are called first differences because you just subtract one time and you get that number. These are called first differences. Now, there is also something, if you do it again, then what you get are second differences. Okay? So if you have your sequence, the first time you subtract these, you get the D, which is the first difference. Okay? So let's talk a little bit about how that works. Let's go up here for a minute. Remember this sequence that we first wrote down? What if instead of A sub 1, what if I started to call these A sub 0, A1, A2, A3, and so on, and then, that would be like AN or whatever, right? How would the formula look then? Instead of A1, then I would have what? A0 plus, but now if I have it that way, at each step, how many of these D's am I adding? The same as N, right? If I start counting from 0, then when N is 1, you add 1, 2. When N is 2, you add 2, 2. When N is 3, you add 3, right? So over here, it'll be A0 plus N times D.
The first one would be A0 plus
0D.
Or because it's A1, so when you add 1, it is. Oh, I see it.
You see it?
Yeah.
Okay, is everybody with me on this? Yeah? Okay. What is A0? Is that an okay, what is the only thing that changes here? Is A0 changing throughout this process? No. Is D changing throughout this process? No. Is N changing throughout the process? Yes. Because N goes from 1 to 2 to 3 to 4 to 5. Okay? So, what if just for, okay, so this is equal to A sub N. Okay, so this is the formula for A sub N now, right? If I start it from 0. Okay? Okay. It's the what? It's A sub N is equal to, what did I have? A0 plus N times D. Okay? Yeah.
Then, so, like, what would A sub 1 be? That would be
A sub 1 would be A sub 0, which is the first number, plus 1 times D. Which is exactly right. It's A sub 0 plus 1 times D.
And in this case, the D is 2. Okay.
The D is always 2. Okay, so now take a look at this, guys. This is a constant, right? And we just said this is a constant as well. Okay, so what kind of a function would that be? If n is the only thing that's a variable that's changing, what kind of a function is that? Linear? Quadratic? It's a linear function, right? What's the linear function that you know of? Like, what's the general form of a linear function that you know? Y equals mx plus b, right? So let's go ahead and write that. Okay, so if you have y equals mx plus b, okay? Now let me rewrite that again. A sub n is equal to, and I'm going to switch the order over there, n d plus a sub naught. Do you see how this is a constant and this is a constant, so these have the same form, right? So going back up here, okay, going back up here, look at that, that's the formula over there. Okay, do you see that? So when you graph those, that's what you get. You get a linear function. So look here, when n is 1, you get a, when n is 0, you get a 5. When n is 1, you get 7. When n is 2, you get 9, and so on and so forth. Okay? All right. So now, what if the first differences are not the same? Okay, what if the first differences are not the same? Then we say, then the sequence is not an arithmetic sequence. Okay? So then you have to look at the second differences. And if you look at the second differences, then you get a quadratic equation. Okay, so let's take a look at this for a minute. Look at the sequence. Okay? What are the first differences here? What's the difference there? What's D? 8. What about here? And here? 14. And then 16. So those are the first differences. What about the second differences? How much is that? 2, 2, 2, and 2. So do you see how the second differences are the same? Yeah? Okay, when the second differences are the same, then this pattern follows a quadratic model. So we have to write an equation now for that quadratic model. So let's go ahead and do that. This is similar to what we did before with the parabolas in the matrix chapter. Okay? So take a look here. When n is 1, what's a sub 1 in that sequence? 12. When n is 2, what's a sub 2? 20. When n is 3, what's a sub 3? 30. So all these can be created into coordinates 1 comma 12, 2 comma 20, 3 comma 30. Are you taking notes? Okay. So now we're going to plug these into the equation that I highlighted over there. So here's the equation we're going to plug them into. A sub n is equal to an squared plus bn plus c. All right?
3 times n squared or a sub n squared?
No, 8 times n squared. Because, so take a look at this. A sub n is the y variable. N is the dependent variable. That's it's the independent variable, like x. Okay? So now we're going to plug the first number in here. Okay, so look, the first number, n is 1. A sub n is 12, right? So we're going to plug that in here. So the term 1 comma 12 becomes 12 equals a times 1 squared plus b times 1 plus c. Right? Now let's do the next one, 2 comma 20. So 20 equals a times 2 squared plus b times 2 plus c. And then we have 3 comma 30. So 30 equals a times 3 squared plus b times 3 plus c. Okay? Yep. Okay. Okay, so what are these equations? Right, they're quadratic equations, but do you see how we have 12 equals a plus b plus c, right? 20 equals 4a plus 2b plus c. Can we turn these into a matrix?
Yeah.
Yes, we can. 1, 1, 1, 12. You thought they were over. They're never over. Okay? So now we're going to use the calculator, or you're going to use your calculators to put in reduced row echelon form. Okay, so go ahead, put them in reduced row echelon form. When you do that, you get the identity matrix here and the cute little numbers on the other side. So this is 1, 5, 6, meaning A is 1, B is 5, C is 6. So A sub n is 1n squared plus 5n plus 6. So now, wouldn't you know it? That's exactly what's graphed for you here. Okay? That's the equation. But what is what is the significance of that equation? Because when you graph that equation now, you see when n is 1, y is 12, or an is 12. When n is 2, we got 20. When n is 3, we get 30. When n is 4, we get this. And with this, what is the benefit? I mean, we have the first 5 numbers, but the benefit now is you can extrapolate this, right? And you can get any number. You can get the, 57,254th number if you wanted to. Okay? Right? So that's how, this is second differences. So when it's first differences, the equation is linear. When it's second differences, the equation is quadratic. Okay? Question?
That's the same as like if you were to plug the number that you wanted into that n.
Right, into the a sub n, right? So before, when we were dealing with, when the first differences are the same and you graph it, you get a linear equation. N equals 1, this is the value. N equals 2, this is the value. You only go up the same amount, okay? All right. So let's talk about series. We're still going. We're going to go. Okay? We're still going to go. I know we have some time tomorrow as well in this section, but I do want to finish series now. Okay, so now, the beautiful thing about Precalc Honors is we don't just take things for what they are, we need to know exactly where they come from. So today, we're going to derive the formulas for arithmetic series. Now, here are the formulas, which again, you have to memorize. These are the sums, these are the formulas for the sum of a finite arithmetic series, right? You have two versions of them. It's either this or this. But we're going to derive them, because why not? Okay, let's do this. What is S sub n? It's when, okay, you add, okay, the first term to the second one. And what is the second term, you say? It's A1 plus D, right? Plus the third term, A1 plus 2D. Okay? And you can keep going until you're blue in the face, but we're not. We're going to go dot, dot, dot. And then plus. Now, the last number is A sub n, correct? What's the one right before that? A sub n minus 1. And what's the one right before that?
A sub n minus 2 times.
A sub n minus, right. So, okay. But, okay, so if you're at the last term, right, how do you get the one right before it? What do? You subtract a D, correct? And then how do you get the one right next to it? You subtract another D, okay? So let's go ahead and do that now. So here, this is going to be AN minus 2D plus AN minus D plus AN. Okay? So I know some of you guys, okay.
This?
I mean, no. No. Okay. Okay. So that's A sub n. That's S sub n. Yes? Okay. So guess what? We're going to write this again. Because why not? I mean, we wrote it once. We can do it again.
Oh, the exact same thing.
Exact same thing. Because why change it if it's not broken? Why fix it? So this is how a lot of these mathematical formulas or proofs come about, right? The theoretical. So people ask, what do mathematicians do? This is what they do. They kind of, you know, look at the theoretical aspects of this. They go, let's add two infinite sums and two finite sums to each other and see what happens. So now we're going to add these two to each other. That's one addition problem. Maybe we can't teach this in elementary school. So what do we get on the left side? Sn plus Sn is 2Sn equal to. Now here's how we do this. It's kind of clever. You kind of pair each of the columns with each other, right? So what do we get for the first one? Oh no. Nope. See? I went after the calculators and then I got, okay. No. We were supposed to have added the second one, but this isn't as much fun as if we had done this in reverse order. That's what we're going to do. We're going to add the second one in reverse order. So start from this and go all the way around. I'm so sorry about that, guys. Here. I'll tell you. So sorry. Well, maybe you can just write over. Let's see. Okay, so we're going to do it the other. I'm so sorry about that. So we're going to do it in reverse order. So AN, and then AN minus D, AN minus 2D, and then A1 plus 2D, A1 plus D, and then A1. Now we're good. Yeah, because we're going to add them by columns like that, right? What do we get in the first column? A1 plus AN. What do we get in the second column? Look, what do we get here when you add these two? A1 plus AN. What do we get here? A1 plus AN. What do we get in all of them? A1 plus AN. All the way to the end, right? They're each going to give you A1 plus AN until you get plus A to the end. A1 plus AN again. Okay? So now, how many of these things do we have? We have N of them, right? So let's write that again. 2SN is equal to N times A1 plus AN. So how do we solve for 1 SN? Divide by 2. So SN is N over 2 A1 plus AN. And now, is this or is this not the first formula in that box?
It is.
It is the first formula in that box. So do you see where it comes from? Yeah? Yeah.
That second one is supposed to be A1 plus AN, but I think you did AN plus AN.
Which one?
For the second parenthesis, or that's the last one.
We just went from finding.
Yeah, it's all A1 plus AN. Huh?
We went from like the formula to find the like digits of the sequence like after and then added it to the formula to find them before.
Well, you just had, it was the same exact thing, but we just wrote it in reverse
No,
order.
but this one's minus. So
Yeah, but we wrote it here, right?
I know. No, I'm talking about like, so here you would use this to find the next digit, and for this you would
Right,
just
because
find
that's
one
the end
before.
of the sequence now. So you have to have like a different way of writing it. Okay?
Okay.
Okay, so now let's do the next one. Let's do the other formula. What question? Yes, ask me.
Why is it in reverse order?
Because if you do it that way, then you see that like each one of the rows will give you the same entry, right? You just get like the same thing repeating, and that's how you can find like a concise formula for how to find it.
Well, yeah, I get that, but like, why is it? I just don't understand like the logic.
So this is what mathematicians do, right? They take something and they look at it, backwards and forwards and, all sorts of ways until they can find a usable pattern that's a more efficient way of solving something.
So there's no real reason.
There's no real reason. This is where like the genius of these mathematicians comes in, right? Yeah. Okay, so so this is what we just came up with, right? But what is AN? Do we have a formula for AN? What did we just come up with about AN, like in the beginning of this lesson? It's A1 plus N minus 1 times D. And if you, put that all together, then SN is N over 2, 2A1 plus N minus 1 times D. And that is the second formula. So that's where the second formula came to us from, right? So these formulas here that are in these cute little boxes in your cute little books, they did not fall into some mathematician's lap when they were like taking a nap or something, right? Somebody like actively sought these out and they, and they found them. Okay. So I guess we can pick up from here tomorrow.
Wait, can you scroll back up loads?
I mean next time. But wait a minute.